Hi folks, so today I want to talk about the pre-calc proving trig identity. So for this video, I'll just show up like some of the basic trig identities such as the Pythagorean, using the reciprocals identity, the ratios. So we'll see some of the examples. So probably that's going to be useful and helpful for for your test tomorrow. Okay, so we'll look at some of the example first. So let's start it off with the basic one. So the basic one, what we got here, it's cotangent square of theta plus cosine square of theta plus sine square of theta. So this one you want to show that's the same as cosecant square of theta. So the way to verify the identity, so you always want to pick the side that's more complicated. Well, obviously the left-hand side looks more complicated, so we just want to verify the left-hand side. And usually students always mix up is that they try to verify both sides. So that's why they end up with something different or try to, it's very easy to mess things up. So let's just verify the left-hand side. So one thing that we notice, cosine square of theta plus sine square of theta, it's 1 because that's the Pythagorean identity. So you guys want to watch the previous video, the way that I proved the identity. And also cotangent square of theta, you want to bring it down. So one thing that we notice, so that's another Pythagorean identity. So cotangent square of theta plus 1, which is considered cosecant square of theta. And compared to the right-hand side, that's exactly the same thing. So we just write down ditto, which is the same as the previous one. So the first one is pretty basic. So now let's do the one that's a little bit more complicated. So for the other one, so we do have sine of theta over. So sine of theta plus cosine of theta. So that equals tangent of theta over 1 plus tangent of theta. Again, compare and contrast, you want to find out the sign that's more complicated. Now, you may notice that the left-hand side, everything is written in terms of sine and cosine already. So nothing we can simplify or reduce. But for the right-hand side, tangent can be written in terms of sine and cosine. So this one, we just pick the right-hand side to verify. So it's tangent of theta, it's considered sine of theta over cosine of theta. And then denominator, so we got 1 plus sine of theta over cosine of theta. So a lot of students might be freaking out with the problem that we just verified. So it looks like it's even more complicated. Well, the thing is that this one is just like going back to algebra 2. It's called the complex fractions. So the way to simplify it is just multiply by the least common denominator, top and the bottom. So you may notice that the least common denominator, top and the bottom, would be cosine of theta. So we just multiply the top and the bottom by cosine of theta. So again, the strategy for this one is called rationalizing. So multiply the top and the bottom, and then cross cancel, and we do have sine of theta. Denominator, you want to distribute, so we do have cosine of theta. And then the second term, cross cancel, we do have sine of theta. And compare back to the left-hand side, what do you guys notice? It's the exact same thing. Ditto. Proof. Alright? So again, sometimes, the problem looks kind of complicated. But once you reduce it, once you rewrite it in terms of sine and cosine, there's so many things that I can do. So rationalizing, that's just considered one of those strategies. So now, we'll take a look at some other problems. So that's even more complicated. Okay, so now the next one I'm going to show you, which is involving with tangent, secant, and cosecant. Okay? So for the next one, so this one is tangent of x over 1 plus secant of x. And then plus 1 over secant of x over tangent of x. So that goes to cosecant of x. And for those students might be wondering, is that always guaranteed that the equation is considered proved? For the practice that we did during class, there's certain problems that they're considered disproved. So once you find out the simplest form on the left-hand side, if that doesn't match the one on the right-hand side, that means it's considered disproved. But now, we'll take a look at this one and see what happened. So the first thing that you want to do, again, nothing we can apply. There's no Pythagorean identity. There's no square. So that means you want to rewrite everything in terms of sine and cosine. So for tangent, just rewrite it in terms of sine and cosine. And then secant, which is the reciprocals of cosine, so it's 1 over cosine of x. And then same thing happened for the second rational expression, so it's 1 over cosine of x. And then tangent, sine over cosine. So we tried to apply the same strategy as what we did for the previous problem. So it's a complex fraction, so that means we can multiply the least common denominator, top and the bottom. So for this one, multiply by cosine of x. Cosine of x. And for this one too, multiply by cosine of x. Again, cross cancel, so we do have sine of x over cosine of x. And then plus 1. Again, this one, after you distribute, you can just cross cancel. And then for the second rational expressions, similar, so cosine of x plus 1 over sine of x. And now we just simplified it into irregular rational expressions. Now at this moment, we can just simply find the least common denominator. So compare and contrast the least common denominator. That's right, it's cosine of x plus 1. The quantity of cosine of x plus 1 times sine of x. And this one too, cosine of x plus 1 times sine of x. And now we want to convert it. We want to convert that from the previous step, the common denominator. So let's find out things that we need to multiply top and the bottom. So it looks like this one is missing sine of x. So we multiply sine of x top and the bottom. And then over here, multiply by cosine of x plus 1. Okay, so just multiply them straight across. So we do have sine square of x. And then over here, try to expand it. It's a trinomial. It's a perfect square trinomial, so it's cosine square of x plus 2 cosine of x. And then plus 1. So one thing that you notice, sine square of x plus cosine square of x. Well, since we do have the same denominator, we can combine those numerator. So this one would be considered 1. And then 1 plus 1, then that'll be 2. So 2 plus 2 cosine of x. Denominator, we just carry one of those over, so it's cosine of x plus 1, quantity of the binomial times sine of x. And now from here, we can just take out the greatest common factor on the top, which is 2. So we have 1 plus cosine of x remaining. And what do you guys notice at this moment? That's right, the common binomial we can reduce. So what's left? 2 over sine of x. And guess what that is? Which is the same as 2 cosecant of x. And that's what we found on the right hand side. Okay. So another one about to show you is the one with the logarithm. You guys do recognize the properties of logarithm, the way to condense, the way to expand. It's about the product to sum, quotient to difference. So let's do the one with the sum to product. It's like a reverse order of the identity. Okay, so the next one I'm about to show you. So it's going to be like this. So anytime they try to verify the identity, always think about any basic identity that you can apply. If there's no basic identity, we can just rewrite it in terms of sine and cosine. But here's one of the special ones. So this one deals with log. So you may notice that the base is not shown. That means the base is always considered what? 10. So log of 1 minus sine of theta plus log of the quantity, 1 plus sine of theta. So this one you want to show that it's the same as 2 log of cosine of theta. Okay, so again, if you want to put the base right here, that's fine. Without using the base, that's also okay. So we do know that's a sum. So recall the property of logarithm. So anytime they see that log base x plus log base b, y, so the way to condense them is like log base b of x times y. So this one's called the sum to product property of logarithm. So what we can do here, we can just rewrite it as log base 10 of 1 minus sine of theta, and then times 1 plus sine of theta. So once you condense it, guess what you can do? It's a difference of two squares. So that means we can multiply the binomials. So we got 1 minus sine squared of theta. So 1 minus sine squared of theta, again, it's the Pythagorean identity. So it's log base 10 of cosine squared of theta. Don't forget about the power. So it's the power. There's another property for logarithm. It's called the power to coefficient. So let's say we do have log base b, x to the power of r. So this one can be written as r, log base b of x. So it's called the power to coefficient logarithm identity. So the power, which is 2, so we can bring it to the front. So log base 10 of cosine of theta. And let's check this. Is that the same as the one on the right hand side? Yes, it is. So ditto. Alright. So any questions that you have, so please put it on the comment box right there for the YouTube channel. So, and hopefully, and I could answer those questions for the next video. Thank you for watching the video today. And if you guys do like it, please subscribe to the channel.